All right, this is what the station rotation looked like for Unit 9 Standard C at the basic level. This is all new stuff, but and probably the first time we've looked at anything like this. So, if the input values of a table, so we're going to use differences in a table to determine what type of function that we're looking at. What we're going to look at today is the ability to determine whether a function is linear or it's quadratic, or we might have to say that it's something else. Okay. So first thing that we have to check is that the input values are evenly spaced. So this is plus 2, plus 2, plus 2, plus 2 every time, so those are all 2 apart, and they are evenly spaced. And then what we're going to do is we're going to come over to the outputs, and for the first difference, I'll label that as a first difference there, we're going to do this number minus the one before it. So 22 minus 46, which is going to be negative 24, and I'm going to kind of write it between those things like that. And then repeat the process. So that was 22 minus 46. Now I'm going to do 6 minus 22, which should be negative, let's see, 22, 16. Okay. That's that one between those two. And now between the 6 and the negative 2, I'm going to do negative 2 minus 6, which is negative 8, and negative 2 minus negative 2, which is 0. Okay. If these numbers were all the same, I would be able to say this function is constant, or is linear. Sorry, not constant. If these were all the same, if these were constant values in here, I'd be able to say that this data was linear, but these are not all the same number, so that's not the case. So I'm going to go into my second differences, which means I'm going to do the differences of the differences and do 3 more subtractions. So negative 16 minus negative 24, I'll go ahead and write this down. Negative 16 minus negative 24 is negative 16 plus 24, which is 8. Okay. This one's going to be negative 8 minus negative 16, so that's negative 8 plus 16, which is 8. And this one is 0 minus negative 8, or 0 plus 8, which is 8. These numbers are all the same, and in these, it says up here, constant second differences mean the data is quadratic. So therefore, these little 3 dots people sometimes use in place of the word therefore. This is quadratic data, which means if I plotted these points, they would all fall on a parabola. Okay, so that's the process in the example, and so see what these next ones would look like. Okay, or actually maybe, yeah, we'll go ahead and do it. So first differences here, 4 minus 2 is 2. 8 minus 4 is 4. 16 minus 8 is 8. 32 minus 16 is 16. So first differences are not constant, so it's not linear. If I do the second ones, a little bit easier numbers to work with. 4 minus 2 is 2. 8 minus 4 is 4. 16 minus 8 is 8. Still not constant. And so all I know at this point is to check for linear, which it's not, or quadratic, which it's not. And so therefore, I would say that it's neither of those, it's something else. But neither is a shorter word than writing something else. Okay. Again, these were all spaced by 1, so I could even do this. So this one, negative 8 to 5 adds 3, adds 3, adds 3, adds 3, so the x's are evenly spaced. 15 minus 48 is negative 33. 0 minus 15 is negative 15. 3 minus 0 is 3. 24 minus 3 is 21. Not linear. Negative 15 minus negative 33 is a positive 18. 3 minus negative 15 is 3 plus 15. That's also 18. 21 minus 3 is also 18. Those are constant in the second differences, therefore this is quadratic. Okay. Let's try this one. 4 minus 5 is negative 1. 1 minus 4 is negative 3. Spacing over here on the x's is good. Up by 1 every time. Negative 4 minus 1 is negative 5. And negative 11 minus negative 4 is a positive, or is a negative 7. 7. Yep, I agree with all that. Again, not constant. So I'm going to try second differences. Negative 3 minus negative 1 is a negative 2. Negative 5 minus negative 3 is negative 2. Negative 7 minus negative 5 also negative 2. And so this one is quadratic. This one over here. Negative 26 minus negative 20 is negative 6. Negative 32 minus negative 26 is negative 6. Negative 38 minus negative 32 is negative 6. Negative 44 minus negative 38 is negative 36. My first differences are constant, therefore this data is linear and all those points would fall on a straight line. Okay, last one on here. I rearranged the table, made it horizontal instead of vertical. The gaps here, I think we've got a little bit of an issue there. I think probably didn't mean to do that. I think this was probably meant to be a negative 4. We'll try to fix that. My intention was certainly not to do that. I probably fat-fingered that when I was doing it. Okay, I got a little bit bigger numbers here, so I'm going to grab my calculator to help me out. This first difference here, I'm going to do negative 112 minus negative 223. That gives me 111. My next one is a negative 37 minus negative 112 is a 75. 2 minus negative 37, which is 2 plus 37. I think I could have done that one without the calculator. 5 minus 2 is 3. And negative 28 minus 5 is negative 33. Okay, so not linear. Do my second differences here. 75 minus 111 is negative 36. 39 minus 75 is negative 36. 3 minus 39 is negative 36. And negative 33 minus 3 is negative 36. Constant second differences again, so this one is quadratic. Assuming this was going to be a negative 4. If this was not a negative 4, this was not even a function because we had outputs, different outputs assigned to the same input. Okay, but that was a typographical error on my part. Okay, that I didn't catch ahead of time. So there is what station rotation for the basic should have looked like.